Okay, so we were working on number 16. I had to stop the last video because third period ended and I had to move on. So I'm going to kind of recap what we were doing for number 19. We were working number 19. So 19, we're dilating the rectangle with a scale factor of 2 from a center of negative 10, 10. So when we do that, that's a 3-step problem because the center is not at the origin, so it's not our regular kind of dilation. So that 3 steps is that you subtract the center, multiply by your scale factor, which in this case is 2, and then add back at the center, which in this case is negative 10, 10. So one student was complaining that that's difficult to remember, so try to come up with something that would make it easier for you to remember. So subtract, multiply, add, SMA, you could think SMA, like, oh, SMA, I have to do this. And I know that's weird, but, you know, sometimes the weird things help you remember. So, okay. So we have, these are our original coordinates, and we went through and we subtracted the center from each of those coordinates, minus, 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 minus. Now, and again, I caution, when you're subtracting these, be careful with those negatives. This is a negative 10, not positive. So you can't just do negative 7 minus 10. That will give you the wrong answer. You have to do negative 7 minus negative 10. And that'll give you the correct answer, which is 3. Okay. Now the other 10 is positive. So for the other 10, when you do 7 minus 10, okay, it's normal. It's just like your regular subtraction. Okay? All right, when we subtract everything, we get 3, negative 3, 5, negative 3, 5, negative 8, and 3, negative 8. And I made a mistake here because I wasn't careful with my negatives, so make sure to be careful with that. Okay, so step 2, we did step 1. Step 2 is to multiply by your scale factor. So we're going to take everything and multiply by 2. Okay, so this is going to become 6, negative 6. 5 times 2 is 10. Negative 3 times 2 is 6. Negative 8 times 2 will be negative 16. 6, and negative 16. Okay, so we multiplied by our scale factor, and then the last step is we need to go add back the center. Okay, so let me get a darker color. Okay, so we're going to add back that negative 10, 10 to each one. And again, be careful with your negatives. Okay. Don't forget that this is a negative 10 and that's a positive 10. Okay, so 6 minus 10 is negative 4. Oh, yeah, so 6 plus a negative 10 would be negative 4. Okay, negative 6 plus 6 gives us 0. 10 plus a negative 10 gives us 0. And then negative 6 plus 10 gives us 4. Okay. 10 plus negative 10 is 0. Negative 16 plus 10 is negative 6. 6 plus negative 10 is negative 4. And negative 16 plus 10 is negative 6. Okay, so those are our final coordinates. Negative 4, 0. 0, 4. 0, negative 6. And negative 4, negative 6. All right, it's number 20. We've got another dilation with a different center, okay, than 0, 0. Thankfully, this time it's only 1 point, so we don't have to do this for all 4 points. This one's a little bit easier. Okay, so SMA, subtract, multiply, add. SMA, I have to do this. Okay, so 5, 7 is our center. And our point is at negative 2, 12. So we're going to start here. We subtract, okay, minus 5, 7. So negative 2 minus 5 gives us negative 7. 12 minus 7 gives us 5. This is our subtract. Multiply by your scale factor, 4.5. Negative 7 times 4.5 gives us negative 31.5. And 5 times 4.5 gives us 22.5. Okay. And then add it back. So adding back that center of 5, 7. So negative 31.5 plus 5, negative 26.5. 22.5 plus 7, 29.5. Okay. All right, so negative 26.5, 29.5. Okay. Says a pentagon RCKTS, it's like rockets, okay, was dilated with the center at the origin and a scale factor of 1/3. Okay. Center at the origin means that you don't have to do all of this. It's a regular kind of dilation. You just multiply by the scale factor. So it says that the coordinate k is at 21, negative 3. What should be the coordinates of k prime? That should be a prime there. So just multiply by the scale factor. 21 times 1/3, negative 3 times 1/3. So 21 times 1/3 is 7. Negative 3 times 1/3 is negative 1. Okay, so that's our new coordinate. 7, negative 1. Is this an enlargement or a reduction? So this is where we want to look at the scale factor. Okay, we can also look at the coordinate. We can see that the coordinates are getting smaller. And then when we look at the scale factor, this is less than 1. Anytime a scale factor is less than 1, that's a reduction in size. It means it's getting smaller. If it were greater than 1, that would be the enlargement. Okay, 22. What is the equation for the line of reflection given the image and pre-image in the graph? So this is one of those problems where the line of reflection is not something that's a nice and neat horizontal line. We can see if we tried to pick a horizontal line, none of those are going to be a perfect line of symmetry, and the same thing goes for a vertical line. So this is one of those weird lines of reflection, which is why it's asking for the equation. So what this problem relates back to, when you're looking for a weird line of reflection, okay, the line of reflection is also a perpendicular bisector. So what this is really asking for is it wants you to find the perpendicular bisector between these two shapes. So we start this problem off by connecting a pair of points. You could connect C to C prime, A to A prime. I'm going to go with B to B prime. So I connect those 2 points with a line. And then keep in mind you are allowed rulers on this test. So if you want one to draw straight lines, just ask your teacher. Okay, so first thing we need to do, if it's a bisector, I need to find the midpoint. So you can kind of eyeball it for this one, it's pretty easy, but you can always double check because the rise and the run should be the same. So we're going up 2 over 1, up 2 over 1. That means I know that that's the midpoint. And then for the perpendicular part, this is where you want to look at the slope. Okay, slopes are opposite reciprocals if they're perpendicular. This means that you change the sign, flip the fraction. So my slope right now, I'm going up 2 over 1. That's my slope. So if I want to do the opposite reciprocal, then that's going to become negative 1 over 2. Okay. So we write equations in the format y equals mx plus b, where m is your slope and b is your y-intercept. So far, we have y is equal to negative 1/2 x. Now we need to go find our y-intercept. So I like to do this by just plotting some other points, using this point as a starting, and then use the slope. So if it's negative 1/2, that means to go down 1 over 2. There's another point. Down 1 over 2. There's another. Down 1 over 2. There's another. And then when you connect those points, you can see that they intersect at y equals, or yeah, where y is negative 1. So our y-intercept is negative 1. Okay? So this is our equation. Y is equal to negative 1/2 x minus 1. Okay, number 23. Leah? Okay, we'll go with Leah. Created a transformation of triangle SBC using the rule xy goes to 2x, 2y to form the new triangle. Which of the following two choices are true about the two triangles? So if we're multiplying both by a scale factor of 2, this is a proportional dilation. Okay. That means it results in similar figures. That's how we're going to answer this question. This is what we're looking for. What are the properties of similar figures is basically what it's asking. So, the triangles are congruent. No. They changed size. This was a dilation, so they're not congruent. Okay. Triangles are similar? Yeah. The new sides are congruent. No. Sides are not congruent. Okay. The new angles are congruent. Now, angles are different because when you have similar figures, this means that the angles are the same. So the angles are congruent, yes, because that's a property of similar figures. Okay. And then last is an enlargement or a reduction. This is multiplying by something greater than 1. So this is an enlargement. Okay. You will have a question on your test that's like this. It's going to give you a proportional dilation and ask which one of these things apply. And so you have to look at your choices, and what you're looking for is which of those are following the properties of similar figures. Similar figures can be different sizes, but they have the same angles. Okay? All right, so that is the review. Good luck on your test tomorrow. Fourth period, do you want to wish them good luck? You can just say it. Good luck.
Do it.
Just do it. Good luck. Okay, bye.